Okay, welcome to Module 6.1 of Information Systems Resource Management about connectivity and telecommunications. Communications is a key aspect of information technology, but it's one that's also sometimes neglected because you only have a few people who are really responsible in comparison to the larger IT group. Sometimes you'll see telecom and network, or the actual phones and networks integrated, but even still, that doesn't represent a significant number of people. They're usually shorthanded in comparison to the larger organization. So let's take a look and see what some of these items are. Telecommunications has changed significantly over the past, obviously, 50 years. We went from the regular analog phones, and now everything is digital. And then now that you have IP over IP telephony, you can have telephone, video, data, voice all over the internet. And a lot of companies are finding a lot of savings in doing that. So we have a lot of advances in communication, things like satellites, point-to-point, point-to-point communications. Everything is opened up because of the internet protocol. So now we can communicate much more frequently and much quicker and much more reliably, which is another key aspect. In telecommunications, IS departments have been responsible for designing, building, maintaining their information highway. So they need to make sure that the building is appropriately fitted with the right piping for, when I say piping, I mean cabling, for communications, that the bandwidth is able to be, the bandwidth is enough for all of the PCs, for all of the servers. Once built, we have all these nodes and links, and we need to be able to connect from point to point. What's interesting now is that a lot of companies are even foregoing some of the wiring that's needed in some cases and just focusing entirely on wireless. Wireless mobility gives a lot of flexibility to where you actually need to have wires plugged in. I don't think it's really going to be complete where you will not have any wires in the building. You're still going to need to connect the wireless access points to the network, to the central network. But what we can see is that certain cubicles or offices may not even have network connections because it's not needed. The difference between the two, though, is important. Wireless communications are a little bit slower than wired communications. They're also vulnerable because they use radio. So that means someone on the outside can actually try and pick the signal. And if they do, even though if it's encrypted, if someone is able to get the key, they're able to read that information. Unlike a wired, you'd actually have to penetrate the network a little bit differently. So that's completely, it's a little bit more secure, a lot more secure in that sense. However, if someone does, most of that communication is not encrypted. We don't talk about encrypting the lines, the actual wired networks. Telecom itself is the basis for the way people and companies work today. Via phone, via voice, via video conferencing, it's becoming more and more part of the way things are done, whether we use the mobile devices or not. The telecom structure of old was originally provided by the government or by monopolies. And the old telecom ma bells and so forth, it cost a lot to implement these infrastructures. Generally now it's been deregulated in the United States. Across the world that's not necessarily the case. But now what we have is we have increased performance and increased capacity, mostly due to a lot of different competition, a lot of different things going on. One of the interesting competition pieces that's occurring right now is we see cable companies getting into the voice area where they wouldn't have done so before. And conversely, the voice companies like Verizon are now getting into the video or providing cable services where things like where Cablevision, say for example, is today. So you have this encroachment because of the way telecommunications has changed. Bandwidth is another key aspect where we are increasing our capacity, allowing us to send even more and more data, and we see it increasing every 5 or 6 months. We're seeing an increase in capacity. What are we able to actually transmit? How quickly we're able to transmit it. The problem in telecommunications is the last mile. Who owns that last point to the end user? Back in 1990s, the monopolies began encountering competition for that last mile. But you still have this concept of the bottleneck, because everything comes down to, it's like taking a hose, right, and trying to funnel all the water into a straw. It's no different. You have a small amount of bandwidth in that last mile, and you're trying to improve that last mile, say, for the end user. Because not everybody can have the big fiber pipe or a dark fiber pipe into their home, as great as that would be, and I would probably be one of the first to sign up. Visualize the world's network as huge fire hoses that circle the globe that can transmit at very high speeds. But then the thing coming into your home might be as small as a 56K line, even though that shouldn't be the case anymore. Most people should have faster speeds, but that was one of the popular speeds, 56 kilobits per second. You're able to transmit a lot of data, but we can't get it to that last piece. So you end up having this bottleneck and slowdowns. That's why the download speeds and upload speeds are managed by the telecommunications companies or the cable companies effectively. So here's a chart that basically will show you the the speeds and the technologies that are associated with it. You have in this realm of 10 megabits per second things like Wi-Fi, cable modem, WLANs, and we go from 11 to 54 megabits per second to T3 line, which is 44 megabits per second. We'll move into these other technologies like microwave LAN, optical fiber, optical wireless, local loop. These are all very cool technologies that you'll never need to know. All you need to know is that there are higher and higher level speeds that serve different purposes. The last mile ones are the ones right down in here on this bottom part. There are some that are a little bit lower here. You get this 9.6 wireless, 2G wireless. Again, 56K modems as an example. Some of you may remember DSL. Again, these are smaller speeds, but as we get further and further down, that's what constitutes your last mile. Everything from that last one on the previous page through these. They all serve a different purpose. They all serve different units, like the 3G wireless, 4G wireless, the T1 lines, the modem lines, the 56K, which are using the regular analog lines. There are reasons why these are out there, but most of the time, if we're talking corporate, you're not talking about those types of speeds. You're talking faster.